Hello, this lesson video is for plain trigonometry and our topic is oblique triangles. Oblique triangles are those triangles which are not right triangles, or any triangle which is not a right triangle is an oblique. It could be that all the angles are acute angles, or it could be one of the angles is an obtuse angle. An oblique triangle can be characterized in 4 different cases. Case 1, SSS. If all the sides are given. Case 2, case AS. 2 sides are given and the angle in between. Case 3, 2 angles are given and 1 side. There's different cases as well, as long as 2 angles are given and 1 side. In case 4, we have 1 angle is given and 2 sides. Alright, if in right triangle we use the Pythagorean theorem, in oblique triangles we will use the laws of sine and cosine. The law of sine is used for cases 3 and 4. So the law of sine is used in these cases. And for case 1 and 2, we will use the law of cosine. We will discuss each through an example. Supposedly, or supposed, we have an oblique triangle here. Let's label the points A, B, and C. So this is B here. This is C, and this is A. Example, if angle A is 40 degrees, this is 40 degrees, angle B is 70 degrees, and side B is equal to 10 centimeter. The question is, what is the measure of the other sides and angle C? Now angle C, this is easier. It's easier to solve for the measure of angle C. Remember that all the angles of the triangle sums up to, or all the measures of the angles of the triangle sums up to 180 degrees. So 180 minus 70 plus 40 degrees is equal to 70 degrees. Therefore, angle C, the measure of angle C is equal to 70 degrees. Now, the law of sine, because this is case 3, where 2 angles are given with 1 side. The law of sine states that A over sine A is equal to B over sine B is equal to C over sine C. The given here, from the original given, we have A and B. So we will use A over sine A is equal to B over sine B. Substituting the given, we have A sine 40 degrees equals B, which is 10 over sine 70 degrees. Take note that our goal is to get the value of A first. So let's do cross multiplication. A, we have A equals 10 sine 40 degrees and then over sine 70 degrees. Let's no longer transfer or multiply this one with A because we're looking for A. Using our calculator, A is equal to, use your calculator to solve for the value of this one. A is equal to approximately 6.84 centimeter. So we have now the value of A, which is 6.84 cm. Okay, now our problem is C. So we have C over sine C equals, we can either use B or A. So this time let's just use B. B over sine B. So we have C over sine 70 degrees equals B, which is 10 over sine 70 degrees. The same process, we do cross multiplication. So we have C 10 sine 70 and over sine 70 degrees. So our C here is, using your calculator, our C is 10. So we have now 10 centimeter. So you can see here, using the law of sine, we're able to solve the unknown sides of a given oblique triangle under case 3, in which two angles are given and one side as well. Now let's have another example using the law of cosine. Again, the law of cosine is applicable for cases 1 and 2. So let me draw another triangle. Alright, let's still label this as A, B, and C. Supposing the given here is A, which is equal to 5, B is equal to 7, and angle C is equal to 65 degrees. This is case number 1, where two sides are given and the in-between angle. The law of cosine, this is the law of cosine, states that this is derived from the Pythagorean theorem. C squared is equal to A squared plus B squared minus 2AB cosine C. B squared equals A squared plus C squared minus 2AC cosine B. A squared is equal to B squared plus C squared minus 2BC cosine A. This is easier to remember. If this is C, cosine C. If this is B, cosine B. This is A, cosine A. So whatever is not around here or not included here, for example, if this is C, so A and B and 2AB. This is B, so A and C and 2AC, and so on. So I hope it's easier to remember. Again, this is the cosine law, and we will use this to solve an oblique triangle under cases 1 and 2. Alright, so let's solve the given problem. The problem is under case number 2, with two sides and an in-between angle is given, and the unknown are angle A and angle B and side C. Right? So the first thing that we can that can be solved is the length of the side opposite to the given angle C. So we can solve first C using the law of cosine. So we have here, using this formula here, we have C squared equals A squared, which is 5, plus B squared, 7 squared, minus 2 times 5 times 7 cosine C, which is 65 degrees. Let's continue. This is 25 plus 49 minus 2 times 5 is 10, times 7 is 70, and then cosine 65 degrees. We have C squared equals 74 minus 70 cosine 65 degrees. C squared is equal to 44.42 using the calculator. So C therefore is the square root of 44.42. C is approximately 6.66. So we have here 6.66. Alright, next we can find either of the two unknown angles. So let us start with angle A. We can choose either law or cosine law or sine law, because we have here now 3 sides in one angle. So therefore we can choose either of the laws. Let's just use here the cosine law. We'll use, because we're going to solve for angle A, we will use this. Okay. So A squared equals B squared. For a while, let's substitute immediately. So we have A is, again, we're going to use this formula. So we have 5 squared equals 7 squared plus 6.66 squared minus 2 times B, which is 7, times C, which is 6.66, and then cosine A. Right? So let's simplify further. This is 25, this is 49, this is 44.42 minus 93.24 cosine A. So simplifying further, we have, this is 25 equals 93.41 minus 93.24 cosine A. Remember that our goal is to solve for cosine A. So let's just move this one here to make it positive. So we have 93.24 cosine A equals 93.41 minus 25. Next we have 93.24 cosine A equals 68.41. So simplifying further, dividing both sides by 93.24, and then we have 93.24. The result is cosine A is equal to 0.734. So using our calculator, we have A is equal to 42. In the table of values of logarithm, we arrive at 42. For the calculator as well, A is equal to 42.80, approximately 42.80 degrees. So we already have the value of A. Now this time, we can solve for the measure of angle B. Remember that the sum of the measures of the angles of a triangle is equal to 180. So therefore, angle B is equal to 180 minus A, which is 42.80, plus C, which is 65 degrees. Simplifying, we have angle B is equal to 72.20 degrees. Now we are able to solve all the measures of the angle and the sides of the oblique triangle. Alright, I hope you are learning something from this lesson video. I'll see you in the next lesson, in the next episode. Goodbye, everyone.